Okay, section 4.2, logarithmic functions. We'll just jump right in the deep end, go with the definition here. For x greater than 0 and b greater than 0, b not equal to 1, y equal log base b of x is equivalent to b to the y equals x. The function f of x equals log base b of x is the logarithmic function with base b. So, what mathematicians have done here is they've done kind of one of their favorite little tricks. They're taking something brand new and say, okay, if you don't understand this brand new thing, we're going to give it to you in something that you might understand. And so they're saying, okay, if you don't really understand this log thing, this log base b of x, here's another form where all the numbers, another form where this statement is true, b to the y equals x. That you should understand, mathematicians are saying, you should understand what exponentials mean. Now you look at it, it's like, no, that doesn't help. I hate logarithms. I'll never understand logarithms. I give up. But logarithms aren't that bad. If we look right here, and then what I have it right down here, what the above is saying is that the logarithmic form of a equal or y equal log base b of x is the same as the exponential form b to the y equals x. I'm like, well, that doesn't help. I still don't know what a logarithm is. But yeah, you can do this. Look at what this here. My logarithm answer. My log is equal to y. My y is equal to a log. Then look over here and see what y is. Y is an exponent. So over here, y is equal to a log. Over here, y is equal to an exponent. Y is equal to a log. Y is an exponent. Logarithms are just exponents. They're very specialized exponents, but they are just exponents. That's all a logarithm is. So they don't have to be all that scary. They are just specialized exponents. Now some terminology. When we have log base b of x, that b is called the base. It's always positive and not 1. The x in log base b of x is called the argument, and it is always positive, strictly positive. So this tells us you can never find the logarithm of a negative number or 0 using real numbers. And in this chapter, we are only doing real numbers. And that's actually a little, that somewhat is misleading. You can never find the log of 0. Log of 0 is always undefined, no matter what type of numbers you're using. But we're only going to use positive numbers, so you can't do the logarithm of negatives or zeros. And make sure your calculator is set for real numbers. Log base 10 of x is called a common log and is usually just written log or just log x. So if a base is not written, it's understood to be 10. And log base e of x is called the natural log, and it's written lnx. Those are the letters L and N, not the number 1. And I said, when we were in the last section, I said, I'll explain, we'll talk about natural logs more, ln right there. That's our natural log symbol. So on the calculator, it's a capital L. In most print things, it's usually a lowercase l, but capital L, lowercase l doesn't matter. Natural log, not the number 1. lnx, natural log of x. And thus the base of the natural log is the number e. So what we're going to do first is we're just going to do some practice writing between the two forms, the exponential form and the logarithmic form. And to do this, I like to use a little fill in the blank thing that we're going to do, and a couple little phrases that help us remember. Notice here, back up here, these two are equivalent. The base of the logarithm is the base of the exponential. So we can say that bases remain bases. And then what we said about logarithms. Logarithms equal exponents, or logarithms give exponents. Logs give exponents. And if you don't like the word give, equal, whatever. So we're going to do a little fill in the blank thing. Write the following equations in their equivalent exponential form. So in exponential form, we have a base to some sort of exponent equals some sort of answer. And then we're just going to fill in the blank. Bases remain bases. So I look up here, log base 2 Bases remain bases. So my base is 2. Logs give, if you don't like the word give, you can put an equal. Logs equal exponents. So my log is equal to 5. So 5 is my exponent. And then I only have one number I haven't used and one answer blank left. So 32. Or making it look a little prettier, getting rid of my fill in the blank structure. Or 2 to the 5th equals 32. And notice that is self-checking. 2 to the 5th is 32. So if you have one that involves only numbers, it should self-check. On to the next one. Same idea. We do need to remember here, when it says natural log of x, that means log base e, except I got that log base e of x equals 2. We're going to use these same words up here. Bases remain bases. Logs give exponents. Logs equal exponents. So I'm going to have a base raised to some sort of exponent equals some sort of answer. Bases remain bases. Log base e. So my base is e. Logarithms equal exponents. Logs give exponents. So my exponent is 2. And then I have one thing that I haven't used, one answer blank left, so x, or getting rid of that structure, e squared equals x. Now this one I can't self-check because there's a variable involved, but if there's not a variable involved, you can self-check. And let's do one more. Again, we're going to remember that that means log base 10 of 100 equals. So we'll go over here. Base, exp for exponent, equals some sort of answer. Bases remain bases. So my base is 10. Logarithms equal exponents. Logarithms give exponents. So my exponent is 2. Got one number left, one blank left and one number, so 100. Or 10 squared equals 100, and that is self-checking. Logarithms just give you exponents. Okay, going the other way, and we're going to use the same words. Bases remain bases. Logs equal exponents. Using the same word, but going in the other order. Write each of the following in logarithmic form. Now, I like exponents, so remember, a square root is the same thing as an exponent of 1/2. So this is 36 to the 1/2. This time we're going to have a log with some sort of base and an argument equal to some sort of answer. There's my fill in the blank structure. Bases remain bases. My base is 36. So log base 36. Logarithms equal exponents. So what is my logarithm equal to? It's equal to this answer over here. Logarithms equal exponents. Where's my exponent? What's my exponent? My exponent is 1/2. So my log has to be equal to 1/2. Then I've got one blank left and one number. So my argument must be 6, or log base 36 of 6 equals 1/2. If you remember those two phrases, bases remain bases and logarithms equal exponents, you can do this. Same thing here. Log to some sort of base, and then an argument equals some sort of answer. Bases remain bases. The base of my exponential statement is 10. So that's the base of my logarithm. Logarithms equal exponents. So logarithms equal exponents. There's what my logarithm is equal to. I've called it answer. My logarithm is equal to an exponent. There's an exponent. So my log has to be equal to x. then I've got one space left and one thing I haven't used, and so the argument has to be 4. Or this would be log base 10 of 4 equals x, or just log 4 equals x, because you don't have to write bases of 10. Base 10 logarithm called a common log, and you don't have to write base 10 if you don't want to. You can, but you don't have to. So if a base isn't written, it's understood to be 10. Couple more. Rewrite each of the following in logarithmic form. Okay, we like exponents, so let's rewrite this guy with an exponent first of all. So remember, a cube root is the same thing as 1/2, or excuse me, a cube root is the same thing as 1/3. And I really don't want a fraction over there, so 8 to the negative third equals 1/2. There's a format that we can work with, that I do a little rewriting so I make it look like this, b to the y equals x. That I can work with. So this, not so much. So cube root, same thing as an exponent of 1/3, but I really don't want this fraction here. So to make it not a fraction, use a negative exponent. And then we can do the same things that we've done before. So we have a log with some sort of base and an argument equals an answer. Bases remain bases. So looking here, my base is 8. Logarithms equal exponents. And so my answer, what is my exponent, or negative 1/3. Then I have one blank left and one number, so 1/2, or log base 8 of 1/2 equals negative 1/3. The parentheses around the 1/2 not particularly important. And one more time, log to some sort of base of some sort of argument equals an answer. And then again, bases remain bases, logs equal exponents. Bases remain bases, so my base is e. Logarithms equal exponents. There's my exponent, so my logarithm has to be equal to 4. And then I've got one space left and one thing I haven't used, so x. Or that'd be log base e of x equals 4, or just natural log ln of x equals 4. Example 3, write the equation in equivalent exponential form and then solve for x. So really more of the same, but this time they said exponential form. So base to some sort of exponent, exp stands for exponent, equals an answer. Bases remain bases, so 5. Logarithms equal exponents, so my exponent is 2. I've got one blank left and one thing I haven't used, x minus 3. We're just turning that around a little bit. X minus 3 equals 5 squared. So it said rewrite, then solve for x. Well, this is not hard. X minus 3 equals 25. Add 3 to both sides. X equals 28. And that's all they wanted there. And we'll end this video and go on to the next problem on the next video.